Now that you've made some calculations, let's take a look at where we are in the process of being able to make our own oscillating reaction. At this point, you've got three different masses. You've calculated how many grams of malonic acid you need to use. You've calculated how many grams of manganese sulfate you need to use, remembering to take into consideration that the manganese sulfate is going to come as MnSO4.H2O. And you've calculated how many grams of the potassium iodate solid you need to use to put into solution number 2. Now that you've calculated this, we need to think about how you're going to go about actually doing this in lab. Page 6 of your notes has a list of steps needed in order to prepare a solution from pure solvent. These steps are assuming that you're starting with a solute that's a solid and that you're able to determine the mass of solute that you've put into your volumetric flask. The first step in this is to measure and record exactly the amount of solute used. This will be close to, but perhaps not exactly the desired amount. Our balances will read to 3 decimal places, so you want to maximize your significant figures here. But, for example, if you've determined that you need 1.2 grams of your solute, and you manage to load on the balance 1.198 grams of the solute, that's close enough. You're close to what you want. You just need to record the exact amount that you use. Then you need to find a volumetric flask. Here are some pictures of volumetric flasks. Volumetric flasks come in a variety of sizes, and you're going to pick the size flask that you need to use to make the amount of solution you need. In your case, you're going to use one of these little guys that holds 25.00 milliliters of solution. In your first step, you are going to put into your flask a small amount of solvent. We're going to use water in our particular case, so you're going to put a little bit of water into the volumetric flask. The next thing you're going to do is add the solute and shake it up to dissolve the solute. The goal here is to leave yourself enough room to shake that you can get the solute completely dissolved. After you've got your solute completely dissolved and you can't see any more solid floating around in the bottom of your flask, you're going to come with a dropper and you're going to add deionized water exactly up to the mark on the volumetric flask. We typically will use a disposable pipette to do this because if you overshoot the mark, you have to dump the entire solution down the drain and start over again. Once you've diluted up to the mark with deionized water, you're going to put the lid back on the flask and shake it a little bit to mix up the solution. Then, based on the actual amount of solute that you used, you're going to calculate the exact concentration to the maximum number of available significant figures of the solution that's in your flask, and then most people stick a little piece of tape on the flask to label what's in their solution and what its molarity is. All of that is going to work very, very well for the malonic acid, the manganese sulfate, and the potassium iodate. The next challenge we have to overcome is producing the 0.080 molar H2SO4. The challenge here is that the H2SO4, unlike the first 3 solutes, isn't going to come as a solid. It's going to come as a slightly more concentrated solution. Most of you can probably see that if we start with a 1.00 molar solution of sulfuric acid, and we desire to have a 0.080 molar solution of sulfuric acid, dilution is the solution to our problem. We just need to take the 1.00 molar solution and add water until we've reduced the concentration to 0.080 molar. The only challenge then is to figure out how much of this 1.00 molar H2SO4 solution to start with, knowing that when we're done with the dilution, we have to have 25.0 milliliters of total solution. To solve that problem, we need to introduce a new equation. This one is called the dilution equation, and it's C1V1 equals C2V2. C1 and V1 are the concentration of what we call the stock solution and the amount of stock solution we want to use. The stock solution is the solution that we're starting with. It's the more concentrated of the 2 solutions. C2 and V2 refer to the diluted concentration, and the volume of diluted solution that we want to have total. Note that V2 is not the volume of water we're going to add. It's the amount of total solution we're going to have when the dilution is complete. To dilute a solution, here's the process we're going to use. Just like before, we're going to add some water to a volumetric flask. An important safety rule in chemistry, as the people in New York would say, do as you oughta, add acid to water. That's because acids tend to get very, very warm when they're undergoing dilution, and having a large quantity of water present serves to absorb a great deal of that thermal energy. After putting some water in the volumetric flask, you're going to add the amount of stock solution, or V1, to the flask, probably using a burette or a pipette, shooting for the amount you want, but again, you don't have to be extremely exact, you just need to get pretty close. You do, however, need to record the exact amount you want, maximizing your significant figures. After adding V1 to the flask, you're going to add deionized water until you have V2, which is the total volume desired, in your volumetric flask. That means you're just going to add water up to the mark. Again, you probably want to use a disposable pipette to make sure you don't overshoot the mark. You're then going to put the lid on the flask and shake it up to mix the solutions, and then calculate the exact concentration. At this point, you should stop your video lesson, and you should do problems number 5 and 6 on your concentration practice problem set. After you've successfully completed problems number 5 and 6 on your concentration practice problem set, I'd like you to go back to your make your own oscillator calculations and make the calculation for how much of this 1.00 molar H2SO4 solution you're going to need in order to get a 0.080 molar solution of sulfuric acid in flask number 2.